All right, so what I'm gonna do with these next set of columns is I'm going to treat a little bit differently, or we're going to have some like angled columns. It's stepping back as it goes up. The floor slabs are smaller as they go up, so we're going to have to do something besides just vertical columns like we've done below. So let me grab my floor slabs here. And I actually do want the bottom one. I don't want the split list because I want to be able to connect this to the one above. So I'm just going to grab this and bring it through here. All right, so we'll work on these down here, but I have my list of floor slabs. And I'm going to do the same thing that we kind of done before where we're dividing them. But what I want to do is I want to divide it by the shortest length. So let's say we can't have, we want to hit 12 feet as our, our target for the spacing of the columns, but we need it to be 12 feet at the smallest slab, right? So we need to be able to account for, or I'm sorry, at the largest slab. So they might be denser at the smallest slab, but we're gonna make sure that it works there. So this is again just a little bit of sort of like construction geometry, parametric pre-thought. So I'm going to take the lengths of all of those. I'm going to sort them. Okay. And then I'm going to do the reverse list again. Reverse list. Take the list item, which is my longest value. And I'm going to divide that by, let's say we want 12. We're going to do smaller columns, but they might be closer. So let's do 12 feet. So let's do we'll do 10, 12, 15. So now we've got 12. So what we're going to do is we know we need 32 columns, or round up to 33, in order to get it working on the largest slab. So we're going to have the same for the smallest. So then all of my slabs, I have that. I'm going to plug that in. So now I've got my list of all my points for my curved slab. I'm going to take these division points, and this gets a little bit tricky here. So I want to be able to connect them to each other. So what I have to do is, again, bear with me here. I'm going to flip this matrix, or wait, you know what? Let me try. I always get confused here. You're going to watch me work through this a little bit. I'm gonna shift this list because I want to be able to connect one floor to the other, right? And then I'm going to graft this. I'm going to graft this. Let me see if this works. Connect those into there. Now see, it's going around. So what I have to do is I'm going to do what's called a flip matrix. So let me, this should work. So let me just plug that into there. And then, but what a flip matrix does is it sort of creates, right now we have a list of, there's like 26 branches with 33 items each. This just makes 33 branches with 26 items each. So it's like, imagine taking an Excel table and flipping the rows and columns. Now I plug that in and we're getting the lines running the way that we want. So what it's doing is it's actually connecting each floor to each floor. Now we also get this extra curve that goes from the top all the way down, which we don't want. That is the last item in this list. So what I'm going to do is I'm going to simplify this tree. We might not need to graft these. Hold on, let me try this again. This goes to here. Yeah, we don't need to graft them, because then what we can do is I can just split this list. This is another trick that you're going to use a lot. You want to remove the last item from the list. So I'm going to split it. I'm going to do a list length, and I'm going to do a subtraction. And this is this. So now I have all my curves and then my last one. So if I just, in a situation like this, to kind of visualize what's happening, sometimes you just grab a curve component and do that. So it's that versus that, right? I want this one that's actually a bunch of small segments of curves, and then we've got what we want. Now, I know from working with this before, I was getting it really hard to use. It was not working very well with the add column component, so I'm going to use this as an opportunity to show you guys how to do what's called the direct shape. And what a direct shape is it's very easy to use, but it's a geometry direct shape. Add geometry direct shape. All you're basically going to do is plug in geometry and give it a category, and it's going to create it. But first, I'm going to create some round columns here for the top. So I'm going to pipe those. I'm going to put an end cap on them, a flat one. And then I'm going to set my radius to be like 3 inches or something. So we have what, a 6-inch pipe? That might be too small. Yeah, let's make this a 12-inch pipe. There we go. All right, cool. So all I'm going to do is plug this geometry into there. It's going to think for a second. If you don't give it a category, it's going to make it a generic model. We'll go back in and give it a category once this is done thinking. It is going to take it shouldn't take too long to process. 13 seconds, not bad. All right, so what I'll do is, and a little side note, if you want to be able to see these, it's in display. Where is it? I always forget where it is to show the view. Where is it to show the speeds? I probably shouldn't have. Let me just Google this quick. I can't even remember how to turn it on. Be right back. Okay, apologize for that. I had to go back. It's been a while since I turned it on. Display, Canvas widgets, profiler. So that'll show you how long it's taking for components to process. MetaHopper, which is a plugin, can do this bottleneck solver or bottleneck navigator. This will show you actually where the heaviest operations in your definition are. So this is also helpful. So right now, this direct shape is the thing that's killing us in terms of time. So that's another note, is that, the native components, the columns, process in less than a second, in fractions of a second, and then the direct shape takes longer. So one, importing is also always going to bog you down a little bit. But let's assign a category to this. We're going to use the same category. It's the same kind of thinking as the type. Right click. I'm going to make this a column. And then just plug that to the category. It may need to reprocess for another 13 seconds or so. But once it does that, it will be good to go. And we'll go take a look in Revit. Okay, so it took a little bit longer to reassign that type. But anyway, if I come back now into Revit, you'll see I have all of these columns in here. And these are all my, oh, you know what I forgot to do was offset the slabs back, but that's okay. But you'll see that this is a column. It's considered a column, but it doesn't have all of the parameters in it that this one does. And that's the difference between a system family and an import. I cannot then manipulate this really in Revit once it's drawn. So I'm stuck with having to always go back to Rhino to edit it. This I can change. I could move this around. I could change the offset. I could change the height. There's lots of different things I could do here. So that's why it's good to, another reason why it's good to try to use native families as much as possible. So let me fix that offset issue. I'll show you guys how to do that. Go back into Rhino. What is this? Sorry, I want to make sure I can save this. I should have saved this a long time ago. Although there's not a lot that's actually occurring in Revit, so if we lost this file, it wouldn't be terrible. Not yet, at least. Okay, so let me set that. Here's my curved floor slabs. I need to watch this. So I'm going to grab these, pull these into there, so I don't have to redo everything I did. Offset this. That is going to be... All right, so here, this says the curve's not planar. The fillet's doing that. It's fine. I can just set the offset plane to be XY and then negative. All right, so now I should have kind of, sorry, I offset it while this is thinking. I basically just offset it in the same way that we did the other ones, and I plugged it into that curve. So before it was doing this, now it's doing it off the offset curve. So it's just going to think for a second. Oh, something happened here. It might have to do with the counts of how many divisions it's doing. Why some of these are acting a little bit strange. That's fun. Why is this happening? Let me see if I can troubleshoot this. So this is giving me, oh, because I know why. Because this, what happens when offset, it actually graphs them. So this was a flattened list. So if I flatten this, it should fix it. So all I'm doing is it's the way that it's dividing them up. It's now like it's doing it by each individual curve, which before, as we mentioned, we didn't want to do that. We didn't want it to measure per curve. We wanted it to measure the longest curve and use that. So yeah, you could see it's fixed itself now. So all I had to do was, that's why grafting and flattening and knowing the difference is important, because this automatically grafted everything. And if this line is dashed, it means it's more than one branch. If it's double line, it means it's one branch with more than one piece of data. And if it's a single line, it's one branch with one piece of data. All right, so now we've got this straightened out. We've got our direct shape imports. I think we're ready to move on to curtain walls and walls. So let's stop for now.